Hello, welcome back. Today we are going to solve problem 12-23 and 12-24. So let's start the 12-23. Statement of problem is determine the equation of elastic curve using the coordinate x1 and x2. Specify the deflection at point C. EI is constant. So you can see this is beam AC where at point C we have external movement that is clockwise, at point B you have a roller support, and at point A you have a pin support. And total length of this beam is 2L, and from A to C we have coordinate that is x1, and from C to A we have coordinate x2. So also due to this loading, the deflection will be like this one. Clear? So what we have to find, we have to find the equation of elastic curve using x1 and x2. That is, for x1 we will find v1 deflection due to deflection of v1 due to x1 coordinate and deflection due to x2 coordinate, and then we will specify the deflection at point C. So we have to find this deflection. We have to find this deflection. This is VC. Clear? So let's start with the solution. So first step, we know that we have the formula that is EI into d square V over dx square is equal to m of x, and we know that this V is deflection. Now the first step will be, if you remove this roller support, so definitely you will be having a reaction force which is RB, and if you remove this pin support, so you will be having a reaction force that is RA. Why I have taken it downward? Because you can see this will cause to move to deflect it downward, so it will be like this one, and this force will cause it to upward, while to keep it in balance this RA should be downward. So we will apply equilibrium condition in order to find RA and RB. So first condition is sum of all movement about point B is equal to 0, and taking the counterclockwise movement as positive. This is point B. Now first force which is producing movement about point B is RA into perpendicular distance is this L, and it is producing counterclockwise movement, so it will be positive. Clear? And the second movement is this external movement which is m naught. This is clockwise, so it will be negative. So I will write RA into L, clear, minus m naught is equal to 0. So from here you will get RA will be equal to m naught by L. So this is your reaction force at point A. Okay, now we'll find the second force, that sum of all force along y direction is equal to 0, and taking the upward force as positive. So you have minus RA plus RB is equal to 0. So RA is minus m naught over L plus RB is equal to 0, and from here you will get RB will be also equal to m naught over L. Okay, now you have both these reaction forces, so we will move toward this equation, and first we will take we'll cut the beam for coordinate x1. So I will write for x1, when you cut it over here, so and you have to draw the free body diagram. So here you have RA, which is m naught by L, and let this length is x1 where you cut the beam, and when you cut it you will be having a shear force V of x1, and there will be external movement that is m1 of x, and let this is 0.1. Now we will find this external moment m1 by using sum of all moment about 0.1 is equal to 0, and taking the counterclockwise movement positive. So first movement is due to this force m over L, and perpendicular distance is x1, and it is counterclockwise, so it will be positive, plus this external movement will be also positive, so their sum must be equal to 0. So I will write m naught over L into x1 plus m1 of x is equal to 0. So from here you will get this m1 of x will be equal to minus m naught over L into x1. So this is the moment equation for coordinate x1. Clear? Now what you have to do is you have to put it in this equation. So for coordinate x1, for x1 we have ei d square v1 over dx1 square is equal to m1 of x, and this m1 of x is actually minus m naught x1 over L. Now you have to integrate it. So once time, so when you integrate it, you will get EI into dv1 over dx1 is equal to minus m naught x1 square over 2L plus C1. Okay. Now we will again integrate it to get the equation of deflection. Again integrate to get the equation of elastic curve. So EI, after integrating it, you will get EI into V1 is equal to minus M naught x1 cube over 6L plus C1x plus C2. Let this is your equation number 1, that is for slope, and this is for deflection. Now I will choose another color and I will take the for it for coordinate x2. So for x2, when you cut the beam over here and you draw the free body diagram, so you can see that this is total length x2. At this end you have external movement which is clockwise, and when you cut it you will be having a shear force. Clear? And that is v2 of x, and there will be a movement which is m2 of x. This is point 2. So from here, when you apply sum of all moment about point 2 is equal to 0 and taking the counterclockwise movement as positive, so you have this movement which is clockwise, so minus m2 of x and minus m naught is equal to 0. So it means that m2 of x is equal to minus m naught. So this is the moment equation for x2 coordinate. Again we have to put it in this formula, ei into d square v2 over dx2, because it is for coordinate x2 is equal to m2 of x, and that will be equal to minus m naught. So integrate it once. So integrate it once. You will get EI into dv2 over dx2. Here there is a square as well. Okay, is equal to minus m naught x minus m naught x2 plus C3. Let this is your equation number 3. And if you again integrate equation 3, you will get EI into V2 is equal to minus m naught x2 square over 2 plus C3 of x2 plus C4. And let this is your equation number 4. Now you can see that C1, C2, C3 and C4 are unknown constant of integration. So we will find them by using boundary condition. So what I have to write boundary conditions. Now you are very well about this. So first boundary condition is at x1 is equal to 0, we have deflection v1 is equal to 0. So you can check it over here. Here you have x1 is equal to 0, so deflection will be 0. So you have to put it in equation 2. Why equation 2? Because equation 2 is for deflection, V1 for coordinate x1. So again, you can see that when you put x1 is equal to 0, so this term will be 0, this term will be 0, and V1 is also 0. So it means that C2 is equal to 0. So I will get C2 is equal to 0. Now the second boundary condition is that at x is equal to x1 is equal to x2 is equal to L. So we have V1 is equal to uh, V2 is equal to 0. So I will show you here. You can see that here we have x1 is equal to L. From this side, R x2 is equal to L from this side. So in both condition you have V1 is equal to V2 is equal to 0. So here deflection will be 0. So you have to put first in equation 2 to get C2, and then put it in equation number 4, this equation. So first we will put in equation number 2. So when you put x is equal to L, so it will be minus m naught L cube over 6L, which will give you minus m naught L square over 6, okay, plus C1 into L. As C2 is equal to 0, so it will be this. So I will put EI into 0, because V1 is 0, is equal to minus m naught L cube over 6L plus C1 into L plus C2, and C2 is equal to 0. So you will get from here 0 is equal to minus m naught L square over 6 plus C1 L. Okay, so when you calculate C1, so C1 will be equal to m naught L over 6. This is the value of C1 and C1. So we have C2 and C1. Now we'll put the same boundary condition, this one, which is which I am going to highlight, this one, in equation number 4, and this is the equation number 4. So when you put V2 is equal to 0, so this side will be equal to 0. So I will write 0 is equal to, this will become equal to minus m naught L square over 2 plus C3 into L plus C4. Okay, so this is your another equation, and this equation is equation number 5. Now we will use the fourth boundary condition by using continuity condition. And what is that continuity condition? This condition is that x1 is equal to x2. We have x1 is equal to x2 is equal to L. At this point, deflection, which is dv1 over x1 due to coordinate x1, will be equal to minus dv2 over dx2. So we are talking about this area at this point. Since you have a deflection like this, so you can see at this point, if you draw a tangent to this one, so slope at this point dv1 over dx1, which is equal to minus dv2 over dx2. Why minus? Because x1 is from this coordinate and x2 is from this coordinate. They are opposite to each other, so angle will be same, but there will be a minus sign. So you have to put this condition x1 is equal to x2 is equal to L in dv1 over dx1, and then put it in dv2 over dx2, and then equate them. So I will write, we have both this equation over here. So what you will do is that if you put this equation 1 and equation number 3. So when you put equation number x1 is equal to L in this equation. So we will having EI into dv1 over dx1 will be equal to minus m naught L square over 2L plus C1. C1 is m naught L over 6. And when you put x2 is equal to L in this equation, so you will get EI into dv2 over dx2 is equal to minus m naught L plus C3. Now if you equate both equation, this equation and this equation, clear, because they are we have this condition, so EI is on both sides, so here you will get dv1 over dx1 will be equal to 1 over EI times m naught minus m naught L square over 2L, which will give you m naught L over 2. Clear? And we will have plus m naught L over 6. Similarly, here you will get dv2 over dx2 is equal to 1 over EI into minus m naught into L plus C3. Now you can equate them. So this will be equal to 1 over E into I into minus m naught L over 2 plus m naught L over 6 will be equal to minus 1 over 2, because there is minus. So 1 over EI into minus m naught L plus C3. 1 over E, 1 over E will be cancelled. So we will be only having this term minus m naught L by 2 plus m naught L by 6 is equal to plus m naught L minus C3. So again, when you solve this, you will get C3 will be equal to 4 m naught L over 3. Now you have this C3, you can put it in equation 5. Put C3 is equal to 4 m naught L over 3 in equation 5 and simplify it. You will get C4 will be equal to 5 m naught L square over 6, and I hope you can do it easily. Okay, now we have C1, C2, C3 and C4. So you can just put C1 and C2 in equation 1 and 2. Clear? So when you put it in equation 1 and 2, so what is the equation 1? Equation 1 is this one. You can see this one. So you will get it, C1 is m naught L over 6. So you will get here, I will write it, instead of C1 you will be having this value. So I will write it, the equation will be equal to EI into dv1 over dx1 is equal to minus m naught x1 square over 2L plus C1. C1 was m naught L over 6. And if you put C1 and C2 in equation number 2, which is equation of elastic curve, this equation. So after putting this, you will get C2 is equal to 0. C2 is equal to 0, so you will get this equation. EI into V1 is equal to minus m naught x1 cube over 6L plus m naught into L divided by 6x1, and C2 are 0. So this is equation of deflection for x1 coordinate, and this is equation of elastic curve for coordinate x1. Now put C3 and C4 in equation 3 and 4. So we need only C3 in equation number, this is your equation number 3. So after putting the value of C3 in this equation, just remember this equation. I will write here equation number 3. So we will get EI into dV2 over dx2 will be equal to minus m naught x2 plus C3, and C3 is 4 m naught L over 3. And when you put it in equation 4, so you will get EI into V2 is equal to minus m naught x2 square over 2 plus C3, which is 4 over m and naught L over 3 plus C4. C4 is 5 m naught L square over 6. Now this is the equation of slope for coordinate x2, and this is equation of elastic curve for coordinate x2. Now we have solved one of its part, that is first one, v1 in term of and v2. So these are the equation. If you divide both side by ei, so here you will get v1 will be equal to 1 over ei times minus m naught x1 cube over 6l plus m naught L x1 over 6. If you further take if you further take m naught over 6 L common, and ei is already there, so we left on minus x1 cube plus L square x1. Okay, you can just do it. This is very easy. So this is the equation of elastic curve for coordinate x1. Now if you divide this equation by ei on both sides, so you will get v2 is equal to 1 over ei into minus m naught x2 square over 2 plus 4 m naught L over 3 plus 5 m naught L square over 6. And again, if you are going to take m naught over 6L common, ei is already there, so you will get simplified form. Here you will left minus 3L x2 square plus 8L square into x2 minus 5L cube. For verification, you can just multiply this term with every term, so you will get this v2. So this is the equation of elastic curve for coordinate x2. Now we will move toward the second part. What we have in second part is that you have to find the deflection at point C. So deflection at point C means that you will be having this, so this deflection VC. So here x2 is equal to 0, so you have to put x2 is equal to 0 in this equation. So put x2 is equal to 0 in v2 equation. So what we will do is that it will be equal to vc, and vc is equal to v2 at x2 is equal to 0. So when you put x2 is equal to 0, so this term will be 0, this term will be 0, and we will left with minus 5L cube over minus 5L cube into m naught over 6 ELI. So I will write minus 5 m naught L cube over 6L EI. Clear? And this minus sign, if you want to remove it, so it will be 5 m naught L cube over 6L. Further simplify, so this L will be crossed with this, and here we will have L2 EI. So this is the deflection at point C. You can also find slope at point C. So put x2 is equal to 0 in dv2 over dx2 in this equation. So when you put x is equal to 0, so this term will be 0 and we will left with dv2 over dx2 will be equal to 4m naught L over 3ei, and this will be the answer. Okay, so when you put it here in equation 2, so you will get dv2 over dx2, which is equal to deflection at point C, slope at point C, and that will be minus it will be equal to 4m naught L over 3ei, and this is the answer of our question part B. Now we will move toward the second question, and you can see the second question is exactly the same figure as above, but instead of solving it from the beginning, we will use the same, we will get the same equation. So here we have been given determine the equation of elastic curve and coordinate using the coordinate x1 and x2 and specify the slope at point A. So we have to find the slope. Rest v1 and v2 will be same that we have derived in this question. So we will use we have been asked to find the slope, so we will use dv1 over dx1 equation, and we will put x1 is equal to 0 in that. So let's move. Where is the equation? I will show you the equation. This is the equation. This is the main equation. So we have to put x1 is equal to 0 in this equation. Okay, so let me put question number. This is question number 2-24, 2-24, where you have to find the slope at point A. So put x is equal to x1 is equal to 0 in this equation. So when you put x is equal to 0, so this will be 0, and we will left with ei into dv1 over dx1 is equal to my m naught L over 6, and this dv1 over dx1 will be equal to theta a. So I will write dv1 over dx1 at x is equal to x1 is equal to 0 is equal to theta a. Okay, and if you want to find this theta a, so theta a will be equal to m naught L over 6 ei, and this is the answer of our this second question, which is question 2-24. So we have saved time as well as we have covered problem 2-24. I hope you have enjoyed both the problem. Again, those who are new to my channel, I will request them to subscribe it and press the bell icon so that they can get notification about my latest video. If you have any question, you can ask me in comment section. Thank you for watching and supporting me. Take care.